Here we have nitrogen, oxygen, N2 molecule, O2 molecule, and we are asked to arrange them in the increasing order of their ionization energy. So what are the factors ionization energy depends on? Yes, ionization energy depends on uh, Z effective nuclear charge. Higher the effective nuclear charge, higher will be the ionization energy. After that, it also depends upon the electronic configuration. Higher the stability of the electronic configuration, higher is the ionization energy. Like we know, half-filled and full-filled configurations are more stable, so those configurations will result in higher ionization energy. And after that, we have penetration power. So S subshell has higher ionization energy compared to the P subshell. Okay, so now let's look at the things given to us. First, we will look at nitrogen and oxygen. So for nitrogen and oxygen, let's write their electronic configuration first. 1s2, 2s2, 2p3. For oxygen, atomic number 8, we have 1s2, 2s2, 2p4. Okay, so now look at this second factor. We have discussed that electronic configuration is the factor which affects ionization energy, which means half-filled and full-filled configurations are more stable. You can see that here. This is a P3, which means half-filled for P. Therefore, nitrogen has a lot more stable electronic configuration compared to oxygen, which means that nitrogen is going to have higher ionization energy compared to oxygen. Okay, so this thing is done. Now let's look at N2 and O2. So for N2 and O2, we are going to draw their molecular orbital diagram, and from there we are going to see what to do. Okay, so for nitrogen, I'm just going to write for 2p because A, 2s and 1s, they do not affect anything, and also they are not, I do not have space available for it. So in p orbital, we have 3 electrons, atomic orbitals, nitrogen, nitrogen, and here. Okay, okay. So because electron is equal to 14, here we have P, and here we have sigma. How many electrons we have total? 6 electrons. So we are going to fill them. 1, 2, 3, 4, 5, 6. All the electrons filled. These are bonding molecular orbitals. For nitrogen, these are atomic molecular orbitals. Okay. And these empty ones are anti-bonding molecular orbitals. Okay, now let's do the same for oxygen. Because oxygen is more electronegative, it is going to have lesser energy. So oxygen has 4 electrons in the outer orbital. So 1, 2, 3, 4, 1, 2, 3, 4. Okay, okay. So we have total 8 electrons, and now we are going to fill them. So this is sigma orbital. E is equal to 16. So this is how it is going to be. This is sigma and this is pi. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now look at these two molecular orbital diagrams. Here oxygen has 2 electrons in the antibonding molecular orbitals, and these 2 electrons, they have higher energy, and from this you can deduce that oxygen will easily give away these 2 electrons easier than nitrogen, because nitrogen has its electron in the bonding molecular orbital. So from here we know that nitrogen molecule is going to have higher ionization energy compared to O2 molecule. Okay, now we will form a relationship between these two. Okay, now look at this nitrogen atomic energy, atomic orbital energy. On now look at this electron. The energy of this electron is here, lower than the atomic orbital energy. So from here we know that energy of N2 is lower than energy of N, energy is of N is lower than O, and energy of O is lower than O2. So this is the order of energy.